Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. So in this lecture, we are going to discuss about SHA algorithm, that is Secure Hash Algorithm 512. Okay, this is a very important algorithm which is used for password storage and military and defense applications. So this type of algorithm is used. So that is the powerhouse of cryptographic hashing. We call this algorithm. Okay, right. Exploring the robust cryptographic foundation that secures our digital world. Right. What is SHA 512? So SHA 512 is secure hash algorithm 512 is a cryptographic hash functions producing fixed output. So this output we call it as message digest. So it accepts 2 to the power of 64 length message. More than 200 power 64 length bits it accepts as the input message and produce fixed, that is 512 fixed output digest. So here that is a function of hash functions. We all know it accepts any input length and produces fixed output digest, right? So part of SHA2 family designed by NSA and standardized by NIST in 2001. It converts any input data into a unique irreversible digital signature. So this powerful algorithm ensures data integrity across countless applications worldwide. Right. Why SHA 512 matters in cybersecurity? What are the important features of SHA 512? It is the main thing is data integrity. Is so my data integrity, collision resistance, and wide. It has very wide applications. Okay, right. So what is data integrity? It provides a strong data integrity verifications. That is data integrity here. It means for a small change in input message, so there is a large change in the hash functions. That thing we call it as data integrity. Second one is collision resistance. What is collision resistance? So practically impossible to find two different inputs that produce the same hash value. Okay, right. So it is very difficult to find two input messages which produce same digest hash functions. That is collision resistance. It's a very important feature of SHA 200 and 512, right? Then it has applications in digital signature, SLC and the transport layer security, SSL and TLS. Okay, okay, right. Then, so how it is working? There are various steps in SHA algorithm. So first one is input formatting, hash buffer initiation, message processing, and final output. In input formatting, the input message is padded with some linked input so that the input message is the number of bits is multiple of 100, 1024. That is input formatting. Right. Then eight buffers are used here. Eight fixed 64-bit constants are buffer used for temporary storage of input data and also the final storage of the message digest. So eight hash buffers are used. Then messages are processed using 80 round functions. Number of round function is 80. Bitwise operations, modular additions, and logical rotations. Finally, will get the message digest of 512 bits, right? So here these are all the different SHA algorithms for various input sizes, various block sizes, and based on the input message and block sizes, number of steps are decided. So SHA 512, there are 80 rounds of operations, right? So this is a major block diagram of SHA 512. So initially the message, input message is appended with, it is padded with some padding bits and length bits of 124, right? After that, input message is segregated into various blocks of 1024 bits. Then each block is processed with some, is facing some round functions, and finally the output message digest is developed, right? So here, this is a single, this is the entire functions where the message is working on goes through these operations for each round. There are 80 rounds from round 0 to round 79. So it faced there are 8 buffers from A, B, C, D, E, F, G, and E of 64 bits. After all these processes, the output comes out like HI here represents. Okay, right. So this is one round operations of SHA algorithm. There are 8 buffers A, B, C, D, E. So here MAJ major and CHR nonlinear functions which depends on various logic gates, logical operations. Then these messages are added and XOR. Finally, the buffer values changed with the new values after this process. Like that, each block is going through various processes, and finally, the message digest will get of 512 bit, right? So, SHA 512 securing the digital future. For securing the digital future, SHA 512 is much essential. So it is a robust foundation and universal adoption. These are some of the features and future resilience. It has a very high resilient algorithm, right? So I come with another new topic in my next lecture. Thank you. Thanks for watching.